Hi there, my name is Pradeep Dhaliwal. Welcome to this MCAT Science Review video on the types of elements. We'll be starting off this video with an explanation of the metals, then the nonmetals, and we'll wrap up with the metalloids. By the end of this video, you'll be able to use the periodic table that you're going to be provided on test day to predict the properties of any element that you might see on the MCAT. And you'll learn to answer questions such as, which of the following elements would be least likely to be found in the wiring of an electrical circuit? The first group we're going to be discussing are the metals, and they're this large blue group of elements found on the left side of the periodic table. If we want to learn a little bit about the atomic properties of metals, we can take magnesium as an example, and here it is pictured below. Because magnesium has so many inner electrons shown here in blue, the valence electrons shown in red experience relatively little of the positive charge of the nucleus because those inner electrons block that charge from reaching them. And so you can say that magnesium has a relatively low effective nuclear charge. That is, the nuclear charge that's felt by the valence electrons. And this low effective nuclear charge is what's responsible for all of the other common atomic properties of metals. That is, they don't attract electrons particularly well. And they also don't hang on to the electrons that they do have particularly strongly. And finally, because the electrons that they have aren't pulled as strongly towards the nucleus, they have a relatively large radius. All of these loosely held electrons are also responsible for a number of physical properties that are characteristic of metals. For instance, with the exception of mercury, they're all dense, shiny solids at standard temperature and pressure. They're also malleable and easy to shape. They're ductile and easy to pull into wires. And finally, they make excellent conductors of both heat and electricity. If we want to look at the nonmetals, we should draw our attention to the yellow group on the top right of the periodic table. And as you can see, the nonmetals are a much smaller group than the metals. We can take an example this time of argon. And the difference you can see here between argon and magnesium is that despite the fact they have the same number of inner electrons, argon has an extra 6 protons to pull on those valence electrons, and so compared to metals, nonmetals have a relatively high effective nuclear charge. And as you can expect, this means that a lot of their atomic properties are opposite to those of the metals. They're very good at attracting electrons and hold on very strongly to the electrons that they do have. And they also pull those electrons much closer to the nucleus, resulting in a much smaller atomic radius. The physical properties of nonmetals also run opposite to those of the metals. They can be in any phase at standard temperature and pressure, and even when they are solid, they're often dull and break before you're able to change their shape. And they also make very poor conductors of heat and electricity. The last group to look at are the metalloids, this stair-step shaped red group between the metals and the nonmetals. As you would expect from their name and their location on the periodic table, the properties of metalloids are somewhere between those of metals and nonmetals. For instance, if we take silicon as an example, it's shiny yet brittle, but can conduct heat and electricity under certain conditions. So if you see metalloids on test day, just remember that they're going to have some traits of metals and some traits of nonmetals. Now that we've reached the end of this video, let's come back to the question from the beginning. The best way to figure out which of these elements would probably not be in an electrical circuit is to first figure out which of the 3 major groups of elements they fall into. And when we do that, we see that we have 2 metals, 1 metalloid, and 1 nonmetal. And now the nonmetal should stick out as the one being from a group that characteristically are always poor conductors of heat and electricity, and so therefore D, nitrogen, would be least likely to be found in an electrical circuit. With the information from this video, you should be comfortable filling in the cells of this chart. The physical properties of metals are that they're solid at standard temperature and pressure, shiny, dense, malleable, ductile, and they make great conductors. And on the atomic level, they have low effective nuclear charge, electronegativity, and ionization energy, while having a large radius. Nonmetals are any phase at STP, they're dull, they're brittle, and they make very poor conductors. On the atomic level, They have a high effective nuclear charge, electronegativity, and ionization energy, while having a very small radius. And metalloids, in both their atomic and physical properties, are intermediate. As long as you can recall all of the information on this chart, you should be in a great place for any questions about the properties of elements that you're going to come across on test day. Well, that brings us to the end of this video. Hopefully now you're an expert on the difference between metals, nonmetals, and metalloids. If there's anything you're still confused about, feel free to go back in the video and give it another watch. Best of luck on your MCAT.